Okay, so chapter 2 looks at transformations. When it comes to this chapter, it's, in a sense, it's a building block for almost the entire course. The stuff that we do in this chapter, we look at again when we do exponents and logs, when we do polynomial functions and rational functions and trigonometric functions. It keeps coming back and back and back. What we look at is we focus on the characteristics of the function. We focus on what these movements are doing to the graph. So it's important to kind of follow the steps. If you keep into that habit of following the same steps each time, when we change the function, it won't change how the graph responds to those transformations that we keep doing. So we're going to look at an understanding of the effects of transformations that move or map a figure from an original position to a new position. In junior high, you did slides, you did flips, and you did turns. What we look at here is we look at slides, which we call translations. We look at flips, which we call reflections. And then we look at stretches. We don't deal with rotations. In particular, we're going to consider replacements for x and or y in the function of y equals f of x and investigate how this function of y minus k equals a times f of b times x minus h plus k is related to that original function. So in other words, what does the k, the h, the a, and the b do to the function? If I replace f of x and I put an h in there, what did that do to the graph? If I put an a in there, what does it do to the graph? So it doesn't matter what the graph is, it will always do the same thing. So if we start off with translations. A translation is a transformation that slides each point on a graph of a figure the same distance in the same direction. So what we're going to look at is comparing the graphs of y equals f of x and y minus k equals f of x, or if I moved the k to the other side of the equation, it would be y equals f of x plus k. But the understanding is I'm replacing or I'm attaching that k with the y coordinate. So my y coordinate is my vertical, it's my up and down coordinate. So part 1 says complete the table of values. The first one has been completed for you. So if x equals -3, I get -3 squared is 9. -2 squared is 4, and so on. And that graph has been drawn for us. If I look at the equation y minus 3 equals x squared, this equation, if I rewrote it, would be x squared plus 3. So if x equals -3, I get -3 squared, which is 9. Add 3 to it, and I get 12. -2 squared is 4. 4 plus 3 is 7. -1 squared is 1 plus 3 is 0 squared plus 3. There we go. And then I get 1 squared plus 4, 2 squared, or sorry, 1 squared plus 3, which would be 4. 2 squared, which would be 4, plus 3 is 7. And 3 squared, which is 9, plus 3 would give me 12. So if I graph these points on the grid, so I get -3 and 12, -2 and 7. That's not where 7 is. -1 and 4, 0 and 3, 1 and 4, 2 and 7, 3 and 12. So this was my y minus k equals x squared graph. Now if I look at the graph drawn in black and the graph drawn in blue, what do you notice? What do you you notice about each of the points?
They're 3 above.
They're 3 above the original points. They moved up 3 each time. So the x values stayed the same, but the y values became 3 more. So if I look at the next equation, which is, instead of having it as a y equals, it's a y plus 3 equals. Again, in order to solve this, if I put negative 3 in there, I get 9. And then I'd have to bring this 3 over. So I could rewrite the equation as an x squared minus 3. So now I get 9 minus 3, which is 6. 4 minus 3, which is 1. And then 1 minus 3, 0 minus 3. And then I get 1 minus 3, 4 minus 3, and 9 minus 3. So now if I graph these 7 points, when x equals negative 3, I get 6. When x equals negative 2, I get 1. When x equals negative 1, I get negative 2, negative 3, negative 2, 1, and 6. So this was y plus 3 equals x squared. So what happened this time? Each point went down 3. So if we go back to the blue graph, the blue table. In this table, I did a replacement. Instead of writing it as a y equals, I wrote it as a y minus 3. So I replaced y with a y minus 3. What did that do to the graph? My blue graph went up by 3 units. So the effect of this replacement is the graph moved up 3 units. Now, I could use better notation and I could say that it translated, because translated is my proper math term for a slide, and it translated vertically 3 units. What happened with the green graph? So in the green graph, I replaced y with a y plus 3. So what did the y plus 3 do to the graph? Translated it down 3 units. So translated vertically 3 units down. Then what I would like you to do is work on the part 2. Okay, so if we look at what I asked you to work on with the graphing calculator and the absolute value functions, the absolute value of x would give you a graph that looked like that. It should actually show that it's going to the origin, like this. And then my absolute value of x plus 2 looks like the entire graph moved up, whereas the absolute value of x minus 3 shows the entire graph moving down. So when I look at the equation, the absolute value of x plus 2, it's taking this original question and making a replacement, adding that 2. That 2 was actually with the y. Because if it was with the x, it would be inside the absolute value symbols. So originally, that 2 was on the other side of the equation. So that's a replacement, is replacing the y with a y minus 2. So how did that impact the graph? What did that do to this graph?
Translated vertically 2 units up.
There we go. So translated vertically 2 units whereas in the other equation, y equals the absolute value of x minus 3, originally that negative 3 was with the y, so it would have looked like y plus 3 equals the absolute value of x. So it's replacing y with a y plus 3, which did what to the graph?
Translated it vertically 3 units down.
Good. So it says based on the results from these two warm-ups, I locked that. What effect does the parameter k have on the function f of x plus k? So what does this k do? Remembering that when I originally wrote it, it would be a y minus k equals f of x. So in that case, when it's a y minus k, what did that do to the graph? It translates it up. So it's a vertical translation. K units up. And then if I have, what is the effect of the parameter k on the graph of the function y minus k equals f of x? Again, it's translating the graph, k units up. So it's the same thing. It's just showing you the two ways that the equation could be written. So again, I have a vertical translation, k units up. And I had asked you to leave e alone. We would talk about e this morning. It says, compared to the graph of y equals f of x, the graph of y minus k equals f of x results in a vertical translation of k units. Now, it's this part in here which always causes the confusion. When k is greater than 0 and when k is less than 0. When k is greater than 0, it looks like this. It's the y minus k. So that was my y minus, or the equation was y minus 2 equaled f of x, or equaled the absolute value of x, became y equals the absolute value of x plus 2. So when k is greater than 0, this graph actually moves up. So the example of that was when I had y minus 2 equals f of x. It then becomes y equals f of x plus 2. When k is less than 0, so that was the one with the plus 3. On this equation, if I have y plus 3 equaled f of x, if I told you that the plus sign was broken, you can't use the plus sign anymore, we are in the land of subtraction, and pluses have been outlawed. How can I write y plus 3 then, if I can't use a positive sign? Minus negative 3. Y minus negative 3 is the same thing as y plus 3. So there's my k is less than 0. This is a negative number. So that moved the graph down. And when I put it over onto the other side of the equation, I get y equals f of x minus 3, or minus k. So what we need to look at is this note here. The notation y minus k equals f of x is used often instead of using y equals f of x plus k. And the reason why we use this notation is we want to emphasize that the transformation is happening to the y coordinate. If I look back at this graph at the top of the page, my x coordinates didn't move. The value of 2 when x equaled 2 didn't move on either graph. It's where the y value went to. In this graph, it went up by 2 units. In this graph, it went down by 3 units. So it's the y value that's being impacted, which is why we like to show it with this notation, y minus k equals f of x. Okay? The next thing that we looked at was looking at the graph of y equals f of x and y equals f of x minus h. So I asked you to fill in these two charts and then to draw the graphs of each of those functions. So if I fill the charts in quickly, I get 16, 9, 4, 1, 0, 1, 4, 9, and 16. So then when I go to graph that, at negative 1 and 16, 0 and 9, 1 and 4. Oh, I don't have 9 in the right place. It should be in the middle. There we go. 2 and 1. And then 3 and 0. 4 and 1. 5 and 4. 6 and 9. And then 7 and 16. So I get this parabola that looks like this. This is my y equals x minus 3 squared. How does that differ from the first parabola?
It was translated 3 units, right?
Yeah, it's moved 3 units to the right this time. So now if I look at the next chart, x plus 3 squared. My values end up being the same, but my inputs were different in each case. So when x equals negative 7, I get a positive 16. Negative 6, I get 9. Negative 5. Negative 4. Negative 3. Negative 2. Negative 1. 0. And 1 and 16. So then I've got this parabola right here. And how does that parabola in blue compare to my original? So how does the one in blue compare to the one in black?
It's translated horizontally
3 units to the left. Okay. So if we go into these two questions, in the second table, x has been replaced with an x minus 3. What is the effect of this replacement on the graph of y equals x squared? I have a horizontal translation, 3 units right. And when I replace x with the x plus 3 as in the last or the third table, I ended up with a horizontal translation, 3 units left. So what I would like you to do now is I would like you to do part 2 using the graphing calculator. Draw these 3 graphs. You don't have to put a sketch of them anywhere, but I want you to tell me what the parameter h has on the graph. Okay, so based on the graph of y equals f of x and the results from parts 1 and 2, what effect does the parameter h have on the function y equals f of x minus h? What does it do to the graph? So in comparison to the square root of x, what did the square root of x minus 4 and the square root of x plus 2 do to the graph? It translated it horizontally. So horizontal translation of h units. So compared to the graph of y equals f of x, the graph of y equals f of x minus h results in a horizontal translation. Now, when h is greater than 0, what that means is my replacement is always in the form of replacing x with an x minus h. So if I go back to the two examples, when I replaced x with an x minus 3, or I replaced x with an x minus 4, which way did the graph move? It moved to the right. So when h is greater than 0, the graph moves to the right. So such as the example, y equals the square root of x minus 4. When h is less than 0, that replacement, again, if I'm in the land of subtraction where plus signs have been outlawed, instead of writing x plus 2, I could rewrite it as x minus negative 2. There's my h being less than 0. So when h is less than 0, I move to the left. Okay? That part there is probably the most confusing aspect of the transformations, because our mind looks at a plus sign and automatically thinks plus means up, plus means right, and all of a sudden now it means something different. It's not that it means something different. It has to do with the replacement and the way that it's written. Replacements are always written as y minus k or x minus h. So when we're looking at the value of k or of h, we're kind of looking at it separately from that minus sign in front of it. So then when k is greater than 0, that's when I move up. When k was less than 0, this would have been written as a y minus negative k. That's why I move down. When it's x minus h, I move to the right. When it's x plus h, I should have written it as an x minus negative h, and that's why I move to the left. These replacements probably become one of the most important things when I'm doing transformations. If I can remember to write the replacements down all the time, I'm less likely to make mistakes in my transformations. It's only when I try to skip that step that I make those common mistakes. So if we look at class example number 1, what happens to the graph of the function f of x if the following changes are made to the equation? So if I replace x with an x plus 2, what would happen to the equation? So first of all, what coordinate's being replaced, x or y? X. So is this horizontal or vertical? Horizontal, because x's are horizontal impacts. So this is a horizontal translation. And I know it's 2 units. The question is it 2 units to the left or 2 units to the right? Why would it be left?
Because it's technically x minus negative 2.
Right. So technically this was x minus negative 2, so this becomes 2 units to the left. Okay. If I look at B, if I replace y with a y minus 8, so I'm replacing which coordinate? Y. So what kind of a translation do I have? I have a vertical translation. And it's 8 units in which direction? Up. So vertical translation, 8 units up. Because the replacement was an y minus k. So that 8 value is a positive 8. So if I look at class example number 2, Describe how the graphs of the following functions relate to the graph of y equals f of x. So what is my replacement? What did I change from the original function of f of x to this new function? I replaced x with what? X minus 3. So this tells me I have a translation of what?
Horizontal translation of 3 units right.
3 units right. And I'll start abbreviating things so that it's shorter to write. What's my replacement on B? How do you know it's with the y?
Because it's not in the brackets.
Because it's, yeah, exactly, it's not in the brackets. So that 4 belongs on the other side with the y. So when I move it to the other side with the y, what do I get? So I replaced y with a y minus 4, which would do what to the graph? Yes. So vertical translation 4 up. What's going on in C?
We have both translations.
You have 2 translations. So what are my 2 replacements?
Y is replaced with y minus 4.
And what does that tell me to do?
1 unit up.
Okay. And then what's the other replacement?
X plus 10.
And what does that tell me to do?
10 units left.
10 units left, because remember this would be an x minus negative 10. I don't expect you to write the x minus negative 10. Okay? So all together, I have a translation of 10 units left and 1 unit up. Better? Okay, if I look at class example number 3, I'm given a point on the graph. The point 2 and negative 3 lies on this graph of f of x. What is going to be the new coordinates under the following transformations? So in A, what have I done from y equals f of x to get to my new equation? What's my replacement?
Y with y plus 8.
Okay, and y with a y plus 8 tells me to do what? So it tells me to go 8 down. Okay, so if I start off with a point of 2 and negative 3, and I move that point 8 units down, where is it going to go? 2 and negative 11. So the x-coordinate did not change because the x-coordinate's not being translated. It's the y-coordinate that was translated. Okay, if I look at B, what are my replacements for B? So start with x. What did I replace x with?
X minus 7.
Okay. And that tells me to do what?
Move 7 to the right.
And what did I replace y with? Y minus 5, because that 5 needs to go back to the other side. And what does that tell me to do? 5 up. So if I take the point 2 and negative 3, if I go 7 to the right, where do I end up? Nine. And if I'm at negative 3 and I go 5 up, where do I end up? 2. that's my new coordinate. Okay, so in class example number 4, we are going to look at writing the equation after the translation or transformation. So again, if we go back to replacements, it'll help us each time. So in A, we have a horizontal translation of 5 units to the left. So if it's horizontal, it's which coordinate? X. So what am I going to replace X with? X plus 5, because I'm going to the left. So in my equation, y equals f, and where I see an x, I replace it with x plus 5. So if I look at B, B is a translation of 3 units up. What would my replacement be? Y with a y minus 3. So what would my equation look like? Right. So I could write it like this first. Y minus 3 equals f of x. And then I could put the 3 over. Or I could do it all in one step. Generally, we do write our equations as a y equals equation, simply because if we go to graph it, we always have x's as our input values. A translation of m units to the right and p units down. So what's my replacement in order to go m units to the right? X minus m. So x to an x minus m. And then p units down as a replacement on y. What will I replace y with? Y plus p, because I'm going down. So then I would have y plus p equals f of x minus m. And then I can move the p to the other side. Y equals f of x minus m, minus p. Now, sometimes you'll be given an equation or a graph, and you'll be asked to do a transformation on that graph. But you're not actually given the equation. So you can't put this into your graphing calculator and then get your calculator to do it for you. You have to go back to the characteristics. So if I look at my equation, my original equation was an f of x. If I want to draw this function, which is f of x minus 2, what was my replacement? What did I replace x with? And what does that tell me to do to the graph? So then all I do is I pick the coordinates on the graph, points that I can see, and I move all of those points to the right 2 and then join them together. And there's my graph. So it's the exact same as the original, it just got shifted over by 2 units. If I look at B, I replaced x with an x plus 3, and I replaced y with a y plus 2. So what does the x plus 3 tell me to do? So I go 3 left. And what does the y plus 2 tell me? 2 down. So again, I take those points on the graph, and now I'm going to move them 3 to the left and 2 down. 3 to the left and 2 down. again, the two graphs would be identical. One is just slid into a different position. Now, the last part compares mapping notation with replacement notation. They're not the same. Mapping notation directly corresponds to the coordinates. Mapping notation corresponds to the equation. So, if I look at the example where the graph of y equals f of x is transformed to the graph of y minus 2 equals f of x minus 3. The replacements, I replaced x with an x minus 3, which tells me to go where? 3 to the right. And if I replace y with a y minus 2, that would tell me to do what? 2 units up. So 3 units to the right and 2 units up. The points with the coordinates 4 and 6 would become 3 to the right, which would be 7, 2 up, which would be 8. So in terms of my mapping notation, it means that I would take my x coordinate and add 3, and take my y coordinate and add 2. This is mapping notation. Actually, mapping notation, we start with the xy. So it looks like that. That's mapping notation. I'm taking the coordinate and I'm mapping it to a new location. So the mapping notation is not the same as the replacement notation. Replacements are always a one-to-one, x to something with x, y to something with y. Whereas a mapping notation is a coordinate. Take this coordinate and move it to this location. Okay? So if I look at class example number 6, it says, state the coordinates of the image of the point -3 and 5 under the translation described by x. The point xy is being mapped to x minus 7 and y minus. So in this case, we are taking the x coordinate of -3 and 5. So I'm taking my coordinates and I'm putting them into that mapping notation. -3 minus 7 and 5 plus 4. So my new coordinates would be where? -3 minus 7? 5 plus 4? So there would be my new coordinates. Question B asks to write the equation after the following translation. So this is a mapping notation. I take the coordinates of x, y, and I'm going to go x minus 6. Well, what is that going to do to the graph if I go x minus 6? So think of, if I take a coordinate and I go x minus 6 with that coordinate, where's the coordinate going to go? To the left. This is going to go 6 units left. And then if I go y plus 1, which way? Up. It's going to go 1 unit up. So the mapping notation is directly what it does to the coordinate. So now in terms of replacement, if I'm going 6 units to the left, what am I going to replace x with? X plus 7, or x plus 6. And if I'm going 1 unit up, what is my replacement? Y to y minus 1. So now in my equation of y equals f of x, I would have y minus 1 equals f of x plus 6. And then I could move the 1 over to write it as a y equals. And I'd have y equals f of x plus 6 plus 1. So there are your questions.